Hello viewers. Today the experiment we are going to discuss is the determination of solubility product by conductometric method. The apparatus required for this method is a conductivity bridge, conductivity cell, and the chemicals are lead acetate, potassium chromate, and 0.1 normal KCl solution. The principle behind this experiment is the solubility of sparingly soluble salt or insoluble salt is extremely low, so that its saturated solution may be regarded as solution of infinite dilution. Hence, the equivalent conductance of saturated solution of sparingly soluble salt is expressed as follow. Lambda C0 is equal to, otherwise lambda 0 is equal to lambda 0 of positive ion and lambda 0 of negative ion. So where the lambda is the equivalent conductance, the 0 refers to the solution of at infinite dilution or as zero concentration. So where the lambda 0 can be related with the solubility of the salt, S is equal to kappa into 1000 divided by lambda 0. Now from the conductance, the specific conductance can be determined. This is as kappa, from which the solubility can be determined. From the solubility product can be determined. So the procedure for this experiment, the first step is to determine the cell constant. For that, prepare a 0.1 normal KCl solution using the conductivity water. The conductance is measured using a standardized conductivity bridge. The conductance of conductivity water also is measured. Step 2, to prepare the saturated solution. For that, about 2 ml of 2 normal lead acetate solution and 2 ml of warm potassium chromate solutions are mixed in a beaker. So in the lead chromate, now it is precipitated, is washed with conductivity water to remove any soluble impurities. Then the residue is transferred to 100 ml beaker along with the little conductivity water, heated to boiling, cooled to the room temperature and filter it. Now the saturated solution of lead chromate is attained. So the conductance of lead chromate is measured using a standardized conductivity bridge, from which the conductance of pure ion of lead chromate, that is lead 2 plus and chromate ion, can be determined by subtracting from the conductance of water. So we know the formula specific conductance kappa is equal to cell constant and the conductance of the salt. So the observation and the calculation. So the first step, conductivity of water is determined as 0.0 into 10 to the power minus 3 per ohm, and conductance of 0.1 normal KCl solution is 13.52 into 10 to the power minus 3 per ohm, from which the conductance of pure potassium chloride salt can be determined by subtracting this 2 as 13.46, from which the specific conductance can be calculated as 0.014536 per ohm per centimeter. From the specific conductance, the cell constant can be determined as the specific conductance, otherwise the cell constant as 1.07 centimeter inverse. The second table, we find the conductance of the lead acetate solution. This is observed as 5.89 into 10 to the power minus 3 per ohm. So from which the conductance of lead acetate salt is 5.83 into 10 to the power minus 3 ohm. We may calculate the specific conductance. The conductance of sparingly soluble salt, say Z. Conductance of sparingly soluble salt alone, that is which is equal to 5.83 into 10 to the power of minus 3 per ohm. The specific conductance is equal to conductance into cell constant. So the cell constant we already discussed and determined, from which the conductance is 6.745 into 10 to the power of minus 3 per ohm per centimeter. The solubility and the solubility product. The solubility S is equal to 1000 into specific conductance divided by equivalent conductance at infinite dilution, where S is equal to solubility, lambda 0 is the equivalent conductance at infinite dilution. So this is the constant value as 153, from which the solubility S is equal to 44.08 10 to the power of minus 3, and the solubility product is equal to multiplication of S into S, which is equal to S square, that is 44.08 10 to the power of minus 3 into 44.08 into 10 to the power of minus 3 will give 1.943 into 10 to the power of minus 3. This is the solubility product of sparingly soluble salt lead chromate.